let's begin to look into this one more interesting problem. Let me see if the recording is happening. Yeah. So here the problem structure is something like this. I will not go much into detail of this problem because I think this is too verbose. Okay. So let's go to here and let's see this. So what basically they are saying is this, that they are giving you an expression consisting of operators plus and multiplication. Okay, and the operand can be only of single digit. Here you see 0, 9, and operators can be into and plus. So now they want you to put parentheses in this particular expression such that the value comes maximum, or parallelly they are asking that the value can come minimum. Now we will not solve for minimum because once we understand how to get the values for maximum, we no longer require to solve it for minimum because the strategy is similar. So like initially for this problem, 1 plus 2 into 3 plus 4 into 5, if you'll see, they put down the parenthesis this way, and if you put this way, then you are getting the maximum value of 1, not 5. And if you don't put any parenthesis, then in that case the natural order of into and plus comes into picture, and the value comes as the minimum value. So this expression will always have value between, no matter what way you put the parenthesis, the value will be always between these minimum and maximum. So now the author asks you, or basically the problem asks you to understand how to print out the maximum and how to print out the minimum for a given expression. It is been coming from ULM algorithm course, so say, okay, alright, so not very sure what is that standing for. So here basically the key point here to notice is this, that the greedy algorithm does not work here, in the sense that some people think it this way, that you always add the additional thing. Okay, like here you put the parenthesis on addition and then do the multiplication as the last operation. It means that multiplication will be the last operand which is being operated, and addition should be done in the first. But since this is a greedy approach, but there is no known, I could not figure out any proof which stands for this greedy approach. So I'm going for dynamic approach. So this problem will go a bit more than coding. We have to understand a bit more about 2D matrix structure. So what basically we are saying is this: 1, 2, 3, 4, 5. So basically there are 5 operands and 3 operators. 1, 2, 3, 4 operators. So we have to apply these 4 operators upon those 5 operands, given the constraint is this. Now we need to understand this problem in a 2D matrix. So what we are going to do is this: the number of operands, I will create a 2D matrix. So here there are total 5 operands. So we will be creating 5 cross 5 2D matrix, and then we will be operating upon that 2D matrix. So basically it is like I comma j, where I is starting from 0 and j is going maximum to the number of the operands, which is 5, and we have to calculate any combination of I and j in between 0 and 5. So for example, where j is always greater than or equal to I. Let us see. I will not go directly to the solution, we will see it here. So basically this was our exact original question. Now we have to figure out the maximum value corresponding to it. So as I discussed, there are 5 operands. So I have created a 5 cross 5 2D matrix, 5 rows and 5 columns. Now we will begin. We will understand first how can you fill this matrix without doing any operation. See this 1 comma 1. So it means starting index 1 and ending index, starting row 1 and column 1. Okay. Now 1 comma 1 always points to this. Okay. So if I write it like I have used this notation 3 comma 5, so it implies basically from the third 3 up to 5. Okay. Now 1 comma 1 means only doing operation on this 1 comma 1. So since there is no operation we can do it, its value will be always equal to 1, which is the operand. Similar way, if you see for 2 comma 2, it will be 2. Similar way 3 comma 3, it will be 3. Similar way 4 comma 4, 4, and similar way 5 comma 5, 5. Now we will start filling it in this. Now we have figured out the whole diagonal way. Now we'll start filling it from bottom to top. So bottom to top, so let's say this is the next one. So now we have to fill row 4 and 4 to 5, basically 4 comma 5. So if we'll go 4 comma 5, then there is only one operation available, multiplication. We are filling it as 20. Okay. Now we are coming here on this, since 3 is already filled, 3 comma 4. So 3 comma 4 only plus is there, one operand is there, 2 operands and one operator. The value can be only 7. Now let's figure out this value. 3, this is the maximum and this is the minimum. It can't change. So basically from here till here, this value, this value, this is same. Now here the scenario is a bit changing. If you will see row 3 and column 5, it means from 3 to 5. So now 3 to 5. So if I say 3 plus 4 into 5, now this expression, we are talking about this expression. This can be calculated here by putting the notation 3 comma 5. We can do 3 comma 3, that is 3 itself, plus exists between here, plus 4 comma 5. The operation between these two operands. So 4 comma 5 will give 20, plus 3, this will give you 23. But the same expression can be calculated other way. It can be calculated 3 comma 4. Okay, so parenthesis put here into 5 comma 5, which is simply 5, and 3 comma 4 is plus operand. So 3 comma 4 converts into 7 into, since here the operator is into 5 comma 5, this is 35. So we have put, since we are considering the maximum value, we have put 35 here. Similar way we are going here. Now we are going from bottom to top. Now for this 2 and 3. So if you will see between 2 and 3, the operands between 2 and 3, you can put a value of 6 only, because there is no other possible value. This is a simple multiplication between 2 and 3. In the similar way, if we will go for